in 1943, a top-secret order was issued to every artillery commander in the Allied forces. The order was written in bold. Absolute violation meant immediate court-martial. The content was simple. You can receive this artillery shell, you can load it, you can keep it in reserve, but under no circumstances fire it over land. If this shell hits the ground without exploding, we lose the war. This wasn't an atomic bomb, not a chemical weapon. From the outside, it looked like a standard 5-inch anti-aircraft round, but inside the nose cone, where there should have been a simple timer, was something that shouldn't exist in the 1940s. A miniature radio station, a transmitter, and receiver the size of a milk bottle, designed to survive being fired at 600 meters per second from a cannon barrel. Engineers called it the VT Fuze. Soldiers called it the funny shell. But history calls it the first smart weapon. And today, we're talking about the moment warfare shifted from a test of skill to a test of physics. The story of the secret that turned the Pacific Ocean into a graveyard for the Japanese Air Force. To understand why this shell was forbidden, you need to understand the math problem killing American sailors in 1942. Picture this. You're a gunner on a U.S. destroyer. A Japanese Zero is diving toward your ship. It's moving at 300 miles per hour. It's weaving. It's small. You're manning a 5-inch gun. You have a time fuse shell. Here's how the old technology worked. You look at the plane. You guess the range. Let's say 1,800 meters. You shout that number to the setter. He turns a metal ring on the nose of the shell to 4 seconds. Load. Fire. The shell flies for exactly 4 seconds, then explodes. If you guessed right, and the plane is exactly where you predicted 4 seconds later, shrapnel tears through the cockpit. You win. But here's the reality of physics. If your estimate was off by half a second, miss. If the pilot turned slightly left, miss. If the shell exploded 50 feet too early or too late, harmless smoke. In 1941, the Navy crunched the numbers. The result was terrifying. It took an average of roughly 2,500 rounds of heavy ammunition to shoot down one airplane. Think about that logistics chain. 2,500 shells, tons of gunpowder, steel, shipping space, all to swat one fly. The sky was full of lead, but empty of hits. We were throwing metal at the sky and hoping for luck. And as Japanese planes got faster, luck was no longer a strategy. The Navy didn't need better gunners. Human reflexes had hit their limit. They needed a shell that knew when to explode. This brings us to one of the greatest engineering paradoxes of World War II. The concept was simple. Put a tiny radar set inside the nose of the shell. As the shell flies, it sends out a radio signal. When that signal bounces off a plane and returns, the shell knows it's close. It detonates. Timers. No guessing. It sounds obvious to us today, but in 1940, this was considered engineering insanity. Why? One word: vacuum tubes. In the 1940s, electronics didn't use silicon chips. They used glass vacuum tubes, essentially tiny, fragile light bulbs. If you dropped a radio on the floor, the tubes shattered. Now imagine taking that fragile glass bulb and bolting it inside a 5-inch artillery shell. When a 5-inch gun fires, the acceleration is violent. We're not talking about 9 Gs like a fighter pilot feels. We're talking about 20,000 Gs. That's 20,000 times the force of gravity, applied in a fraction of a second. And it gets worse. The rifling of the barrel spins the shell to stabilize it. That spin rate is 25,000 revolutions per minute. The engineers at Johns Hopkins University, specifically a covert group called Section T, were told to build a radio that could survive being hit by a train and then spun at the speed of a centrifuge. If you put a standard radio tube in that environment, It doesn't just break, it liquefies. The glass turns to dust. The metal filaments flatten like pancakes. Most experts said it was impossible, a waste of resources. But Section T didn't listen. They began experimenting with something called potting. They took the glass tubes and encased them in wax, and later specialized plastics. They suspended the electronics in a solid block of shock-absorbing material. They redesigned the glass structure itself, making it smaller, thicker, more squat. They fired thousands of test rounds. They failed. They failed again. I want to pause here, because this is the unglamorous part of war that wins battles. It wasn't about a hero charging a hill. It was about a guy in a lab coat figuring out how to stop a filament from vibrating itself to death at 25,000 RPM. By late 1942, they had done it. They had a working prototype. They called it the VT Fuze. VT stood for variable time. That was a lie. A deliberate counter-intelligence lie. They wanted the Germans and Japanese to think it was just a better timer. If the enemy knew it was radar, knew it was a proximity sensor, they could develop jamming technology. Or worse, they could copy it. That's why the order was given. Do not fire over land. If a dud shell landed in German territory, and a Nazi engineer opened it up and saw a radar set, the secret was out. But the ocean hides its secrets. January 5, 1943. The South Pacific. The light cruiser USS Helena. This is the moment theory became reality. A Japanese HE-D3A Val dive bomber appeared on the horizon, lining up for an attack run. The gunners on the Helena loaded the new Mark 32 shells, the first batch of VT fuses to reach the fleet. Normally, the gunnery officer would be shouting time settings. Fuse 5 seconds, fuse 4 seconds. This time, the order was simply, load VT. The gunners tracked the plane. They fired. Here's what makes the VT Fuze terrifying. With a normal shell, you have to hit the plane or get incredibly close. With the VT Fuze, the shell just has to get near the plane. It creates a sphere of death roughly 70 feet wide. The first shell didn't hit the valve. It didn't have to. It sensed the reflection of the aircraft's aluminum skin. The radar triggered the detonator. The shell exploded alongside the cockpit. The valve didn't just smoke. It didn't just lose altitude. Witnesses said it disintegrated. It was there. And then it was a cloud of debris falling into the sea. The gunners were stunned. They hadn't bracketed the target. They hadn't walked the fire in. They just pointed and fired. The math had changed. We had moved from hitting a bullet with a bullet to area denial. This was the death of skill. You no longer needed 20 years of artillery experience to shoot down a plane. You just needed to get the shell in the same zip code. And the vacuum tubes did the rest. The kill rate skyrocketed. Remember that 2,500 rounds per kill figure? With the VT Fuze, it dropped to roughly 500 rounds per kill. We became 5 times more lethal overnight. But the biggest test was yet to come. Because in 1944 and 1945, the Japanese stopped trying to bomb ships. They started trying to become the bombs. By 1945, the Pacific War had turned into a slaughter. The Japanese Navy was desperate. They launched the Kamikaze, the divine wind. This changed the tactical problem for American gunners completely. When a pilot is trying to bomb you, he wants to survive. He breaks off his run if the fire gets too heavy. But a Kamikaze, he doesn't care about survival. He cares about impact. Traditional anti-aircraft fire relies on damaging the plane enough that the pilot aborts or loses control. But if you shoot the wing off a Kamikaze, who is 500 yards away, his momentum will still carry him into your ship. You don't need to damage him. You need to erase him. You need to turn the plane into confetti before it gets close. The VT Fuze was the only weapon on Earth capable of doing this reliably. The Navy flooded the fleet with these shells. They created a tactic called the Big Blue Blanket. Every gun in the task force would link up to radar and fill the sky with proximity shells. Imagine being a Japanese pilot in 1945. You're flying at 300 miles per hour. You see the American ships. You expect to see tracers. You expect to see explosions behind you or below you as they try to guess your range. Instead, you fly into a wall. The VT fuses were creating a continuous curtain of shrapnel. They were detonating 50 feet in front of the planes, sending steel shards directly through the engine blocks and the cockpits. It was a meat grinder. There are reports from the Battle of Okinawa of Japanese planes literally dissolving in mid-air. No fire, no smoke trail, just structural failure caused by hundreds of simultaneous detonations. The illegal shell had saved the fleet. The legacy of the VT Fuze goes far beyond World War II. If you look at a modern Patriot missile, or the Iron Dome in Israel, or even the air-to-air missiles on an F-35, they are all descendants of that glass vacuum tube inside a 5-inch shell. It taught the military a lesson that defines warfare today. Precision beats volume. We stopped trying to overwhelm the enemy with thousands of dumb rounds and started using smart rounds that could think for themselves. But there's a darker chapter to this story. Remember the ban on firing over land. In December 1944, during the Battle of the Bulge, the Germans were pushing hard. The Allied lines were breaking. General Eisenhower looked at the situation and made a decision. He lifted the ban. The U.S. Army turned their 55mm howitzers, huge artillery guns, against German infantry in the forests of the Ardennes. They loaded VT fuses. Before this, artillery shells hit the ground and exploded. They dug craters. If you were in a foxhole, you were safe. But the VT fuse, it didn't hit the ground. It sensed the earth coming up and detonated 30 feet above the soldiers' heads. It rained shrapnel downward. There was no cover. Foxholes became graves. German soldiers who survived described it as magical fire. They couldn't understand how the Americans could make shells explode in mid-air every single time at exactly the right height. It broke the back of the German infantry assaults, but it was a terrifying unleashing of technology against human flesh. We often talk about the atomic bomb as the scientific breakthrough of the war, and it was, but the atomic bomb ended the war. The VT Fuze won the war. Without the VT Fuze, the U.S. Navy would have been blood dry by Kamikaze attacks off Okinawa. The supply lines would have been severed. The invasion of Europe might have stalled in the Ardennes. The United States produced 22 million of these fuses by the end of the war. It was a miracle of mass production. We took a delicate, impossible piece of electronics, and we built it like we were building toasters. And here's the uncomfortable truth. The romance of the ace pilot or the dead eye gunner. This device killed that romance. It proved that in modern war, math beats courage. A Japanese pilot could have 1,000 hours of flight time. He could have the spirit of a samurai. He could be the bravest man in the sky, and none of it mattered, because he was flying against a $5 vacuum tube that didn't feel fear, didn't blink, and didn't miss. The VT Fuze removed the human element from the kill, and in doing so, it paved the way for the automated, push-button warfare we live with today. If you found this breakdown fascinating, hit that subscribe button. We're building a library of the most tactical, gritty history on the internet, and we want you in the briefing room. Here's a question for you to answer in the comments. The ban on using the VT Fuze over land was held for years to protect the secret. Do you think Eisenhower was right to lift it for the Battle of Bulge? Or was the risk of the Nazis stealing the tech too high? Let me know your take below. Next time, we're looking at the other side of the hill, the German attempts to build guided missiles, and why they failed. where the Allies succeeded. Until then, keep your powder dry. This is WW2 Battlegrounds.